Now that we have looked at the symbolic representation of a line and scatter plots to review the knowledge we need for regression, we're now going to go through a couple of examples using the calculator on finding the regression equation. Now, just a quick reminder that the method that the calculator uses is called least squares, which is a way that the calculator uses to find the smallest distances between the points and the line. So that way the line literally comes as close as it possibly can to all the points. So this question states that a random sample of 11 statistics students produced the following data, where X is the third exam score out of 80 points, and Y is the final exam score out of 200 points. Can we predict the final exam score of a random student if you know the third exam? So what we're going to do is we're going to put our X's in our L1 and our Y's in the L2. And so now let me shift over to the calculator to show you how to perform regression. To perform linear regression on the calculator and to access your R and your R squared value, let's first make sure that our calculator is set up to give us that information. Now you only have to do this once. Once you do it, it's set up. So don't worry about doing this every time you perform regression. So we're going to go above the 0 button. You're going to look in the blue, it says catalog. So to access catalog, I'm going to hit second 0. And then what's going to happen is all the possible commands that the calculator have is going to show up in alphabetical order under the catalog. So what you want to do is you want to scroll down and find the command that says diagnostic on. So you're going to scroll down and look for the D's and look for diagnostic on. Okay, so the diagnostic off and diagnostic on. Make sure that you're clicking diagnostic on. When you hit enter, it will bring you back to your home screen. Then you hit enter one more time and it will say done. Now you're set up so that you will get your R and your R squared value when you perform your linear regression. So what we're going to do is we're going to go to the stat button and we're going to go under edit. I'm going to put my X's in L1, which is the third exam score. And our L2 is going to be our Y's, which is the final exam score. I have mine preloaded in, so make sure you take a minute, pause the video, and enter your data values in there. Once you have your data values in there, to perform regression, you hit the stat button, and then you're going to arrow over to calculate. When you scroll down, you'll see option number 4. It says linear regression, and then it gives you the general form AX plus B. Now, we typically use MX plus B. Keep in mind that the M and the A are the same. Whatever that value is in front of the X is your slope. So we're going to scroll down and choose option number 4, and I'm going to hit enter. Then I'm going to tell the calculator which values or which list I have my X's in and which list I have my Y's in. So make sure that you have those in there. If you forget where to access your list buttons, it's above your 1 and your 2. So you'll have to hit the second button first. Then what you're going to do where it says store regression equation, this isn't mandatory to do this, but it's very, very helpful. If you hit the vars button here and you scroll over to Y bars and you choose function, you can tell it to store your equation in Y1 so that later we can graph it. Now there's other ways to get that Y1 up here. If you know of another way, that's fine. And again, that's not something you have to do, but it is helpful. Now, for those of you who don't have this model calculator where it comes up like this, what you're going to do is when you have linear regression come back up on your home screen with an open parentheses, you're going to put L1, comma, L2 for your X's, comma, your Y's. And then if you want to put in where you want to store it, then you do comma again and put in your Y1. Then I'm going to choose calculate. And it's going to give me my value for A, my value for B, so I can plug it in and come up with my equation. And then it's going to give me my R and my R squared value. So I know what my coefficient of determination is and my correlation coefficient. Now, the nice thing about storing it, if I go back and I click on the Y equals button, you'll see that it has all the digits. It saved all those values for me in my equation here. If I go up to stat plot now and I make sure I have my scatter plot on and I hit zoom 9 to graph my data, it will show me my data values and it will show me my line that I'm using to estimate. Because the calculator used the linear regression method of least squares, that is literally the line that comes the closest to all of those points. So going back, let's walk through that one more time. So to do linear regression, once you have your X's and Y values into your list, you're going to hit the stat button. You're going to go over to calculate and you're going to choose option number 4. You're going to put in your L1 and your L2 or whatever values you have your list. If you have the other model, remember you have your X list, comma, your Y list. And then if you want to store your equation, you can put it here. When I hit calculate, it gives you all the information about the line. So make sure you copy this information down, and I'm going to show you how you can set up your equation using this information now. Looking at the screen, here's your general equation that the calculator gives you. Then it tells you that A is 4.83. Let's round to two decimal places. And then it tells you that B is negative 173.51. So now I can use those values and create my equation. So I'm going to plug in my A value. So I have 4.83, which is my slope, times X, plus my value of B, which is negative 173.51. So here's my equation. X is the score on the third exam, and Y is the score on the final exam. All right, and the next question, it says, what is the slope, and interpret its meaning in the context of this problem? So our slope, that's the number that's in front of our X. So that's this number right here. Of course, we rounded it, but our slope is going to be 4.83. Now, any number, we can write it over 1 like this, and it still means the same thing, right? 5 over 1 is 5, 6 over 1 is 6. So we can rewrite it like this, and that will help us interpret what this means. Because remember, the slope is showing us how one quantity changes with the other. The change in Y is on the top, and the change in X is on the bottom. The change in Y represents the change in the points for the final exam. I'm going to abbreviate since I'm running out of room. And then the change in X, since X represents the exam, the third exam score, this is going to be the change in the points for exam 3. So what this is telling me, if I color code this, the change in the points for the final exam is 4.83. When the points for the third exam is 1, and because it's positive, that means it's increasing. So I would say for each increase of 1 point in the third exam, the score of the final exam changes by approximately 4.83 points. Now, if this was negative, when one increases, the other one will decrease. But because this is positive, they're both going to increase together. The next question says, use the equation to predict the final exam score of a random student if you know the third exam score is 75. So we know the third exam score is 75. And when we look at how we labeled everything, the third exam score was our x. So 75 is x. And when we use our equation, we have y equals 4.83x minus 173 0.51. If we know the value of x and we're trying to find the value of y, which is the final exam score, then we can plug in x is 75 and figure out what y is. So I'm going to replace x with 75. That was this x here. I'm replacing it. And I'm going to put that in on the calculator and see what I get. So I'm going to take 4.83 times 75, and then I'm going to subtract 173.51. When I do that, I'm going to get 188.74. So the last question in the first example says, what is the value of r and r squared, and interpret their meaning? Well, when we did linear regression, we got that r was 0.66 if we round to two places, and we got that r squared was 0.44 if we round to two places. So r tells us, remember, how close the line is to the points, the correlation. It's a strong correlation the closer it is to 1. If it's a positive value of r, that means it has a positive slope. So in this case, I would say r is equal to 0.66, which tells us that there is a positive correlation, which means as one variable increases, the other one increases. They both increase or decrease together. And that the correlation has moderate strength. It's not in the 80s and 90s, which would be a really good correlation. It's not really low where it's weak, like it's where it's 0.3 or 4, where it's really weak. It's somewhere in the middle. So I would describe this as having a moderate strength. Now the r squared is a percentage or a ratio. That 0.44 means that 44% of the variation can be explained by the changes in the third exam scores, where 56%, because that's the complement of 44%, where 56% of the variation cannot be explained. So that's going to be due to something unpredicted that happens or some kind of error. All right, let's look at the second example. It says scuba divers have a maximum dive time that they cannot exceed when going to different depths. The data shows the different depths with the maximum dive times in minutes. Use your calculator to find the least squares regression line and predict the maximum dive time for 110 feet. So let's switch over to the calculator so we can enter the data and find the regression equation. So go ahead and take a minute and put your values of X for your depth in feet and your L1 and the maximum dive time in L2, which are your Y values. Once you're done with that, we're going to hit the stat button and I'm going to arrow over to calculate and I'm going to go down and choose option number 4, linear regression. I'm going to hit enter. I'm going to tell the calculator where I put my X's and my Y's, and I'm going to store my regression equation in my Y1 so I can access that by hitting the vars button, arrowing over to Y vars, choosing function, and then enter on Y1. Then I'm going to hit the calculate command, and it's going to give me all the information for my linear regression. It's going to give me that my A is negative 1.11, B is 127.24, rounding to 2 places, and then I'll write down the R squared and the R as well. R is negative 0.96, and R squared is 0.93. All right, now let's take a look at the scatter plot with the line. If you hit Y equals and you saved it in there, you'll see your line with all the digits saved in there. If you don't see the line in there, you can enter it manually yourself. When you hit the zoom button and you hit zoom number 9, you can see that your line comes pretty close to all these points. So it's a pretty good fit. So here are all your data values in red, and then your linear function or your linear equation is in the blue. So writing down all that information, I now have what I need to plug in to get my equation. So I have Y equals, and then I'm going to plug in my value for A, which is negative 1.11, and times X, plus my value of B, which is 127.24. So this is my linear regression equation. Now it asks, what is the slope, and interpret it in the meaning of the context of the problem. So my slope is the number that's in front of my X. So my slope is negative 1.11, and we can rewrite that with a 1 underneath. Now this is a negative slope, so as one of the quantities decrease, the other one is going to increase. They're going to do the opposite directions. Now remember, Y, the change in Y goes on the top, and in this case, the Y represents the dive time. My horizontal change is in the denominator, and my horizontal change is the depth in feet. So I can interpret this as my depth increases by each foot. The time for diving decreases by approximately 1.11 minutes. So we know our equation is Y equals negative 1.11x plus 127.24, and x is the depth, and that gives us that the depth is 110 feet, and we want to figure out the estimated dive time when the depth is 110 feet. So I'm going to take 110 and plug it in for x, and then we're going to add 127.24, and we're going to put all of this in on the calculator. When I use order of operations on the calculator and I figure out what y is, you should get 5.14. So this tells me when we're at a depth of 110 feet underwater, the dive time should be about 5.14 minutes. Okay, now for the R and the R squared value. We said R was negative 0.96. Negative tells us that it's a negative correlation. And the fact that it's so close to 1, it's 0.96, tells me that it's a very strong correlation. So I'm going to write down that there is a negative and strong correlation between the two quantities, depth and dive time. Now the R squared value we got was 0.93, which would be 93 as a percent. And that tells me that 93% of the variation can be explained by the change in the depth. So it's something that we can account for. We know what that is. So 7%, which is the complement of 93, 7% of the variation cannot be explained. All right, now the last thing I want to mention, I added it down here with stars. When you're doing regression, a lot of times, because we're looking at how one quantity is related to another quantity, sometimes we get in our heads that one variable causes another one to change. And that's not necessarily true. You can have a relationship between two quantities, but one quantity doesn't necessarily mean that it causes the other variable to change. So here's the example that I like to use because I think it's kind of funny. It says, example, does eating ice cream cause sharks to bite? Now, so scientists have found that as the number of ice cream cones go up that are eaten, the number of shark bites that are reported, the number of shark bites go up. That doesn't mean that ice cream causes sharks to bite at the beach. What it means is that probably because it's during that same season, sharks usually bite when people are swimming in the ocean, which happens during the summer. That's when usually people are swimming in the ocean. But also the number of ice cream cones that people eat also go up in the summertime. So there's a relationship there. As one goes up, the other one goes up, but it doesn't mean that eating ice cream causes sharks to bite. So keep that in mind, that you can have a relationship between two quantities, but not necessarily one variable causes change in another variable.